This is number 19. We have a photoelectron spectrum of nitrogen, and I'm going to make a note to myself on my periodic table. That's the first one. And they've given us fluorine, so we also know fluorine. And it's looking to me like what's going to be going on here is a periodicity question. So they're saying we've got these two. They want to know what would be the binding energy of the 1s electrons in oxygen, which they haven't given us the spectrum of, but they want us to pull some information from these two and make some predictions. Well, first of all, we've got to figure out what we think is the 1s electron. Is it A, B, or C in each one of these? Because B and C look pretty similar. You might be tempted to think oxygen would be almost the same. Well, remember that the 1s electrons have the most binding energy. They should have really high binding energy because they're close to the nucleus. So I think A is the 1s electrons in each case. So now we know we're looking at peak A. And you might be willing to say, well, oxygen is between nitrogen and fluorine, so shouldn't its A peak be somewhere in here in the middle of this one and that one? And I think that actually does turn out to be the answer. You know, if you pick an answer between 400 and 700-ish, you see there's an answer down there, that's probably going to be right. But more importantly, we got to get into why. Why are the 1s electrons in a different place for each one of these? Well, remember that a nitrogen atom in its nucleus, right, this 1s electron that's right here, in nitrogen, its nuclear charge would have 7 protons in it. Fluorine has 9 protons in it. So you can imagine that if fluorine has 9 positive charges, that's a much more attractive nucleus to these electrons, and that's why you're seeing a really high binding energy of 700. Whereas nitrogen's a lot less because it has less strong of a nuclear charge. So yes, oxygen, having 8 protons in its nucleus, is going to have kind of an in-between nuclear charge, and that's why its 1s peaks will be in between those two. So there you go. I think the answer is 400 to 700.